Today what we're looking at is how to find the slope of a line. So if you remember back to Algebra 1, slope is simply the change in y divided by the change in x, and we represent that as delta y over delta x. And really what that looks like algebraically is a y value minus another value of y divided by an x value minus another value of x. So y2 minus y1 over x2 minus x1. In terms of functions, we can think of slope of a line as being f of b minus f of a divided by b minus a. So if I take those two things and I connect my dots here, that's not a very good line, but what this represents is the slope of the line that connects a to b, or rather f of a to f of b. And so this would be the slope of a secant line, and we know that slopes of secant lines measure average rates of change, or what we call AROC. Now, if I wanted to find the slope of a tangent line, I can denote that as m with a subscript of t, just to let us know that we're finding the slope of a tangent. And really what that's going to be equal to is dy divided by dx, or the derivative at a specific point. So if I think of dy dx as being similar to delta y over delta x, I'm taking 2 points that are so close together that they're not even recognizable as distinctly different points. So I have 2 points that are infinitely close together, and what that does is that creates a tangent line on my curve. And so the slope of this line can be represented by the derivative dy dx, or f prime of c. So I take the x value c and plug it into my derivative f prime of x to get my slope. Now let's look at an example. So find the slope of the line tangent to the function f of x equals natural log of x minus 4 at the specific x value x equals 5. So first what I want to do is I want to find my derivative. I want to find f prime of x. So remember the rule for natural logs is going to say take the derivative of what's inside the natural log. So the derivative of x minus 4 is 1. And then divide that by what's inside the natural log. And I have x minus 4. To find the slope at the specific point, I'm going to plug in my x value. So I'm going to plug in 5. So I get 1 over 5 minus 4, which is 1 over 1, which gives me a value of 1. So what this tells me is that the slope of the line that's tangent to the function f of x at the point x equals 5 is 1.